All right, we're in Chapter 2, Lesson 3 for IM 3. This is rate of change and slope. So we're still definitely in review mode from a lot of the other math classes we've taken. It's just a very quick review. So rate of change is a ratio that compares how much one quantity changes on average relative to another quantity, which is the basic idea of rate of change there. If the x is the independent variable and the y is the dependent variable, then rate of change is change of y over change of x. Now we can write this little delta symbol, which they tell us it means, delta means change. So it's just another way you might see it is delta y, delta x. It means change in y, change in x. Slope of a line is the ratio of the change in y coordinates to the corresponding change in x coordinates. So same kind of idea. Now we're just applying it to a coordinate grid. So rate of change and slope are pretty much the same idea, but rate of change is just a ratio that compares quantities. Slope specifically compares the y coordinates to the x coordinates. So it's a little blurry down here. Sorry about that, but the notes page came out a bit blurry there. Suppose a line passes through points at x1, y1, and x2, y2. Remember, when we do coordinates, it always goes x then y. So if we have more than one coordinate, instead of saying x, y, xy, we have x1 and y1. That means point 1. And x2, y2, that means point 2. So we always want to label them just so that we know. And then when we plug these in, we can look at the change in y over the change in x. So it's y2 minus y1 and x2 minus x1. So we always subtract the y's from the and then the x's from each other. So you don't kind of flip-flop them or anything like that. So it's always kind of, remember, rise over run. So rise means the y's, because that's how we go up or down, and run means the x's, because that's how we go left or right. So rise and run is just a quick way to help you remember which way we put the coordinates. So we can see that over here, the change in y over the change in x, and I know it's very blurry here, but we can see how it's changing by a certain number. And on this one, we could actually look at the coordinates if we wanted to. They're still using x and y, but we can literally see this is 1, 2, 3, 4. So I'd go over 4 to the right and then up 1, 2, 3, 4. So this coordinate is 4, 4. And then this coordinate, I have to go over, let's see, 1, 2, 3, 4 more. So it's 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is 4, 4, and 8, 8. So I have to go up 1, 2, 3. Oh, did I count that wrong? 1, 2, 3, 4. Oh, that's only 7. Sorry, I had counted 1 too many because it's a little blurry there. So that makes sense because I go up 3 and I go right 4. So my slope here would be 3/4. And I can see that if I look at the coordinates, since I know it's 4, 4, I have 4 and 4 for my y1 and my x1, and I'm going to subtract y2 and x2. So remember that was 8 and 7. So my x was 8, my y was 7. So if I subtract, I get 3/4. So I can see it visually, or I can plug in my coordinates and get the same answer. So either way, I would get the same fraction there. All right, let's go ahead and take a look at the problems they give us on the next page. Let's scooch down a little bit. And I apologize, the notes page was still a little blurry here. I'm going to switch over to blue instead of using that neon green. The graph at the right shows the number of gallons of water in a swimming pool as it is being filled. So this shows us a positive line. It's going up. As time moves forward, the water in gallons is going up. So you can see time moving forward, water going up. So I can see this positive relationship. Dang it, sorry. And I can also see that it is a straight line, which means that it has a constant rate of fill. It's not like going up a little and then slowing down and speeding up. It's going up at a constant rate. So it's saying at what rate is the pool being filled? So if we have 3, and I'm pretty sure that's 108. I can actually look in the book, I believe. Yeah, 3 and 108, just to confirm. And then this next one is 7 and 252, like this. So it's the y2 minus y1 over x2 minus x1. So we want to subtract. So we go 252, and we're 252, and we're going to subtract 108, and we get 144. And then 7 minus 3 is 4, so we go 144 divided by 4, and we get 36. So at what rate is the pool being filled? And I can say 36 over 1, which, remember, this is Y's, which is gallons, and this is time in minutes. So it's 36 gallons per minute. So it's another way to think about that. It's 36 gallons for every minute. You could also use the coordinates here. I've actually done this before where I just stack them and I subtract. You have to be careful because this is a little upside down. So I'd end up with negative numbers on both, and I'd have to flip that around. But I've also done that kind of method too, if you've ever seen that before. But this is pretty darn easy to plug it in. You could also use the graph and say what's my rise over my run, and do it that way. Part of the problem with this one is it's skip counting. So you have to make sure every square you go up, you're not going up by 1, you're going up by 30. Because each one of these represents 30 gallons. All right, the next one here, it says find the slope of the line through each pair of points or of the line itself here. So slope is the change in y's over the change in x. It's the same idea as the rate of change. So I have my x, my y, my x, my y. I'm going to do the same thing I did up here. I have y2 minus y1 and x2 minus x1. 12 minus 2 is 10. 8 minus 3 is 5. So if I divide this, I get 5. Sorry, not 5. That was crazy. 10 divided by 5 is 2. I could say 2 over 1, but really when I have it like that, I can just say 2. That's perfectly fine as well. Keep in mind that it's rise over run when we're doing slope. So we kind of want to keep in mind that when we rise up 2, we run 1. And they're both positive, so this is going to be up, and this is positive, so it's going to be right. So I'm going to go up 2, right 1, up 2, right 1. So keep in mind this 1 is here. The proper way to write it is just 2. It's a slope of 2, but the 1 is underneath it. All right, so we're going to do the same thing on this guy. So we have y2 minus y1, x2 minus x1. And this minus is part of the actual formula. So that doesn't count as the negative here. The negative also gets thrown in. So when I hear minus negative, that becomes a positive. That's 2 negatives. All right, so negative 8 minus 4. So this is one I've actually had students get confused. Well, you just turn these 2 negatives into positive. Why aren't you turning these 2 into positive? They're not touching like they were down here. So it's not a double negative where it's minus negative. And they're not being multiplied. They're being subtracted from each other. It's negative 8 minus 4. So it's a different situation. So in this case, I have negative 8. I'm going 4 more negative. So I go to negative 12. 3 plus 1, I get 4. I'm going to reduce. Negative 12 does divide into 4, and I get negative 3. Sorry, 4 divides into negative 12. I said that backwards. Over 1. So this is negative. That means I'm going to go down 3. This is positive, which means I'm going to go right 1. So it's just my pattern. I'm going to go down 3, right 1, down 3, right 1. And that's how I create my pattern there. All right, when you're doing it from a graph, you want to make sure that you pick points that are kind of right over the cross because that's really easy to calculate. So I would pick these 2 points because they look like they are right over the kind of crisscross there. So this is 0. I'm not going right or left, so it's 0. But I do go up to, let's see, it looks like they're counting by 4s. So this would be 20. This one I'm going over, and this is also counting by 4s. So this would be 20. And we're going to go up to, it looks like 32 right there. Because that's right on the crosshairs. So you don't want to do it, like, you can really pick anywhere on this line that you would like. But if you start estimating, like if I picked this point right here, well, I don't know exactly what this is. I could guess it's a little more than 4, or I could even go right on top of 4, but now I have to guess at what it is over here because it's not right in line with 1. So try to make it easier on yourself by doing that. So we have y2 minus y1 and x2 minus x1. So 32 minus 20 is 12. 20 minus 0 is 20. I'm going to reduce. They can both divide by at least 2. So I can do 6 and 5. So 6/5. And I can test that out. I can go 1, 2, 3. And that would be actually 12. And then 1, 2, 3, 4, 5, which would be 20. So I go up 12, and I go over 20. So I do, in fact, do this pattern, but it's not the reduction. But this is the way Alex is going to want to see it. If you type in 12 20ths, it's most likely going to give you a warning saying it is not reduced. So keep that in mind. We do need to reduce it. All right, that is section 3 here, and I will see you. I want to make sure I said that right. Yep, section 3, and I will see you in section 4.